Let's get started. So first things first, we're going to start off with the following. In terms of your notation, we're going to start off with the first one. The first notation can either be f of x is less than 0, or you can also have f of x is greater than 0. Now, for all of this, I would like for you to always note one specific thing. For that specific note, always remember that in this case, you are talking about specifically all on the x-axis. Now, this means the first one, when you say it's all about the x-axis, it means that the first one, when you say that f of x is less than 0, we are specifically saying that this is going to be below the x-axis. And then, which also means that this one would mean that it is going to be above the x-axis. So it is always best that you remember that. 1 minute on the clock. Please take it down. So continuing from there, let's do some practical examples on it. So the first things first, I'm going to pull up a graph here like that. And then we're going to place a parabola. Let's make it something like this. That first point is going to be -1. This point here is going to be, let's place it as 2. In this particular instance, like I said before, our main focus is going to be on the x-axis. Whether it's going to be above or below, that is based on the question. So in this case, we're going to start off with f of x is greater than 0. Nokukanya, help me out. What is my answer going to be if I'm looking for where f of x is greater than 0?
It's going to be, if of x greater than 0, it's going to be between -1 and 2, so the curve above.
So this part here, as always, you can always shade in so that you know what you're doing. I actually recommend it a lot. Shade in whatever it is that you think is going to be above. So in this case, Nokanya, am I working with a loop, or am I working with, or not a loop?
Working with a loop.
So if it is a loop, it then means that we're going to say that x has to be less than 2, but greater than -1. And that would be your answer, specifically for where you're looking for f of x is greater than 0. Now, if we switch it around and say that I'm now looking very same graph, I'm now saying where is f of x less than 0? Shonaka, help me out.
Where x is smaller than -1 but bigger than 2.
So in this case, we're looking for where it is actually going to be. If it's below the x-axis, it starts here, going all the way to positive infinity, right? Then it also starts here, going all the way to negative infinity. So you can always place your x's based on where the arrows are. So like that, meaning that in this case, x has to be greater than 2, and also x has to be less than -1. And that's how you're able to make it work. Any questions, any parts you don't fully understand? Let's discuss it. Let's talk about it. If there are no questions, 2 minutes on the board. You may write it down. All right. All right then. So continuing from here, we're now going to go to the next part. For the next part, we're going to go on and discuss the following to say that we now have, let's call this your second type of notation. For your second type of notation, let's talk multiplication in any form. So f of x multiplied by g of x has to be, let's say, greater than or equal to 0, which also means that you can have f of x multiplied by g of x is also going to be less than or equal to 0. In this particular case, whenever you have this, it means that you're doing a comparison between two graphs. your main focus has to be on the answer that you're supposed to get. Now, when we say that the answer that you're supposed to get, it's either the answer for our scenarios here, as you can see, greater than or equal to 0 means that this is going to be positive, and less than 0 would mean that it is going to be negative. Your main focus is going to be those answers to be able to see exactly what your answer is supposed to be. Now, once you have your answer figured out, we can therefore go on and say that we're now looking specifically for what multiplication of these two would be able to give us a positive. So in this particular case, we can say that if we're looking for a positive, this means both of them have to be positive when multiplying together. A positive multiplying a positive would give you a positive. Another scenario would be a negative multiplying a negative would give you a positive. Now let's talk about these in terms of what I mean by positive and what I mean by negative. Based off of this, we can say that the positive would mean we are specifically saying that it is going to be above the x-axis. And then the negative would mean that it is going to be below the x-axis. So in this particular case, the one that we have here as both positives would refer to that as saying that both graphs f of x and g of x would need to be above the x-axis. This is where you actually have to be able to shade it in to be able to see if you are right or wrong. Then from there, the negative would refer to the fact that both graphs would need to be below the x-axis. I'm going to stop here for now. 1 minute to write everything down. Continuing from there then. So we figured out that in this particular case of multiplication, you're looking at both graphs actually being either both above or both below. Now let's look at the one that is less than. So for this side, I'll be pushing completely to one side. There you go. In this particular case, we're looking for where it is less than 0. This then means that we can start here to say that in order for this to be negative, one graph has to be positive while the other graph has to be negative. Now we can also do that as well to say that if this graph here now is negative, this graph has to be positive. Just like we applied before, we are saying that the plus would be above, the negative would be below the x-axis. So in this case, for the first part of our graph where we need to shade in, we can be able to say that it would be one graph has to be above. So we're looking for, to specify our graphs, f of x has to be above and g of x has to be below the x-axis. Now these work hand in hand. That's why I'm not saying or, I'm using and for a specific reason. We can't just say that, okay, this one's above, so we give the answer for that. It doesn't work like that. You need one of them to be above and the other one to be below. Specifically, f of x needs to be above and g of x needs to be below for you to get your answer. If you find out that both of them are above, it doesn't work. If both of them are below, it doesn't work. You need it to be in that specific order. And then in this case, for the second part of it, the one that we wrote in green, let's change the color for that. We are saying that f of x has to be below the x-axis and g of x has to now be above. So in this scenario, we can say that they both need to be able to work together for you to be able to get your answer. If you have any questions, reach out, send a text. Let's see what we can do. Okay, there we go. With that being said, let's move. I am going to pick a practical example for this. Let's do something that looks like this. So considering that, I'm going to take a Cartesian plane in this case. From a Cartesian plane, let's make the parabola positive, and let's call the parabola f of x. Then we are also going to take that as our straight line graph, and let's call that g of x. In this scenario, we're going to work specifically. I'm going to pull the x values. As you can see, this passes through the origin. And let's call that x value there. Let's call it 3. Let's do it as 3. So in this particular case, we're going to go on and say we have 2 questions specifically where f of x multiplied by g of x is going to be greater than 0. And then our second question, I'll put it on the other side to say that I will be looking for specifically where f of x multiplied by g of x would be less than 0. So please take down the question and then let's go ahead and do it. Let's get started. So from here, we're going to be looking specifically in this case. Jonaka, can you please help me out? My final answer for this, is it going to be positive or negative?
Positive.
Positive. So what are the 2 parts of the graph? What does it need to be?
Positive and positive, or negative and negative.
Positive and positive, negative and negative. So we're going to say that for the first one, we're looking for where both graphs are going to be above, as well as where both graphs are going to be below. So help me out here. Where are both graphs above the x-axis? Let's start off with...
Oh.
Go ahead. Sonaka?
Oh.
Yes.
When x is bigger than 3.
When x is greater than 3. There we go. So from here, going forward, I really suggest using your highlighters. If you have them, it usually helps. So that part would work. So we can give our answer to say that x is going to be greater than 3 for that. Now in this case, always note that this section here, change the color for it, this part here won't work simply because one graph is now above and the other one is below. So that won't work. And the last one is the same scenario where one graph is above and the other one is below, so it won't work. So in this case, x going forward all the way to positive infinity, that's where it's going to work. There we go. With that, let's look for where both graphs are below the x-axis. Oba, help me out.
For example, if when x is less than 3, I guess. Or
Nah, it won't apply. You see, in this case, g of x is above the x-axis. Remember, our reference point is the x-axis, right?
If x is less or equal to 0?
No. In this case, this one starts going up, this one starts going down.
No.
And this one is down and that one is up, so it won't work. So for this particular case, you only have one answer, and that answer is going to be where x is going to be greater than 3. Please take it down. Let's put a minute on it. Then we can continue. Okay. Next up, we go to the other side. For this, we are now looking for where f of x times g of x is going to be less than 0. Oba, help me out. My answer for less than 0, does that mean positive or negative?
It means negative.
Negative. So what do my graphs have to be for me to end up with a negative? Start with f of x, please.
F of x either has to be above.
So positive.
It has to be either positive and g of x has to be negative, or f of x has to be negative and g of x has to be
positive.
Positive.
There we go. In that particular scenario, we are saying that we need a combination of graphs to say that one graph, so they're either going to be, one is going to be below, whereas the other one is going to be above, and then the other graph has to be above, whereas the other graph has to be below. So this is the combination that we need. Now, it's always easier to eliminate what we already know, to say that from this point here, as we figured out last time, one of it is going to be above and the other one is going to be below. So from 3 going forward, that is going to be a no-no. That will not work, right? Then we go to the other parts of our graph. Now we can always divide our graphs into from x to x. So I'm going to divide it until they're in black, and then I'll create another point in between there, and then I'll be able to create the final point from there onwards. So let's talk about the part in black. Does that apply or does that not apply? I'm looking for where one graph is above and the other graph is below. Noku, what do you think?
I think that it does apply.
Okay, under which condition?
Between 0 and 3.
Yes, under which condition? F of x is positive, negative, g of x is positive, negative.
Oh,
which combination?
G of x is positive. G of x is positive and f of x is negative.
G of x is positive and f of x is negative. I agree with that. Let's color it properly. So that's the black. So we can say that part works. And then, Sonaka, what do you think about the one in red?
It does apply.
Under which condition?
F of x is positive and g of x is negative.
There we go. Just like that, we have our answers. So the first part, for what we know, we can say that it is going to be the first loop. So we can say in this particular scenario, x is going to be less than 3, but greater than 0 as our first answer. And then we can also say that x in this particular case is going to be less than 0. It is always allowed for you to do a combination of these, but I always prefer that if you're going to do it, write it out the way that it's supposed to be. And that's how it works. That's your graph. So try your best. If you can shade it in, it is always best for you to do so. It will always give you an idea as to what you're working with. Please take it down. Let's move on.
Positive. Okay. If f of x is positive and g of x is positive.
X is positive, g of x is positive. Do you have another one?
If f of x is negative and g of x is negative.
So this means that for this scenario, both graphs have to be above. Let's use a color difference here so we can see what we're talking about. They both have to be above the x-axis, or both graphs have to be below the x-axis. Below the x-axis. Let's take a minute, write everything down. So, continuing from here, let's go on. We figured out that both of them have to be above or both have to be below the x-axis. Let's go on to the next one. So Naka, please help me out for the next one. My answer, less than 0, positive or negative?
Negative.
Negative. So what am I looking at? What are the combinations that will give me a negative?
If g of x is positive and f of x is negative, or if f of x is positive and g of x is negative.
Yeah. Negative and positive. So with that, we can start off with the following to say that both graphs, the combination that we're going to need to have is that one graph, f of x, would need to be above and g of x would need to be below the x-axis. And then we are saying that f of x, I have that the other way around in color, but so f of x is going to be below, and g of x would have to be above the x-axis. So that is the combination that you're going to have to work with. So from here, let's go on to a practical example. So using a practical, let's start with the following. I think this would do. Let's take that for a parabola, and this point here, let's place that as -2. That point there would be +3, and let's take one more passing through the 3. That. And in this case, we're going to switch them around. This is now g of x, and this is now f of x. From here, let's go on to say that we're going to look for where f of x divided by g of x is going to be greater than, let's make it less than 0. It's going to be less than 0. Please take it down, then we can go in. Continue. So from here, we have the following. We're saying that f of x divided by g of x is going to be greater than 0. It's going to be less than 0, rather. Over. So, what am I looking at? My answer here, positive or negative?
It's negative.
Negative. And then, Noku, can I please have those combinations, please?
It's either f of x is positive and g of x is negative, or when f of x is negative and g of x is positive.
Yeah, positive. So we're looking for the combination where one is above and the other one is below. So I go again and I cut it through where I have my x values, which is there, as well as there. Those are the two parts that I have, my defined x values. So let's begin. Starting off on the far right, in this case, let's shade it in black. And then let's do the center in green. And last but not least, let's do it in red. There. Go. So those are the 3 parts that I need to be able to work on. Now, starting off with the first part, let's talk about it. Oba, the first part, would that work or not? The one that is in black.
No, it would not work.
Okay, why do you think so?
They're both negative. Both graphs are negative.
Both graphs are below, so that won't work. Let's go on to the second part. So Naka, the green part, will that work or not?
It won't work.
So why is that?
They're both above the x-axis.
Both are above, so that won't work either. Noku, the last part, the one that's in red, will that work or not?
It would work.
Why is that?
F of x is above, while g of x is below the x-axis.
So it means that the combination that we're using is going to be this one. That would work. So in this case, we can just place, since everything's going towards negative infinity, x has to be less than negative 2. And that would be your answer. So like I said before, I'm a big fan of you having to shade in all the parts that you think, where you have your x's, and then just take it from there. It should always be able to work throughout. From here, let's continue on to the last 2 that we're going to be discussing. So the last part, I always try my best to be able to combine these 2. So if there's any parts that you'd like me to reiterate, please do tell me so that I'm able to do it for you. So for the last part, which is going to be 3/4, is now going to be f of x is going to be greater than g of x. And with that, I also mix this in with f of x is going to be specifically equal to g of x. In this case, equal to g of x. So for the first part, we are now specifically working with this as a comparison between 2 graphs, okay? It's not going to specifically be you saying it's now above or below the x-axis. That's done. We are now comparing the 2 graphs. We are saying that in this case, the answer here means that we're looking for where f of x is going to be above g of x, and if it was the other way around, we'd look for where f of x is going to be below g of x. So it means you are now comparing the 2 graphs, which means that if you are comparing 2 graphs, you need this part here, which is going to be f of x is equal to g of x. That is going to be your point or points of intersection. This is where your graphs would actually have the same value throughout. So that's the point where they meet and they're going to have the same value. So they would have the same x value, to be specific. So you need to either calculate for f of x is equal to g of x before you do f of x is greater than or less than g of x. Please always remember that. I'll give you a few minutes to write that down, then we can continue.